In this video, we're talking about Laplace transforms and how to find the Laplace transform of a function using the definition of the Laplace transform. Sometimes you're going to have a table of Laplace transform formulas, and you're just going to be able to match up the function you've been given to the table and use that formula to just transform the function directly. But in this case, we've been asked to use the definition, and the definition of the Laplace transform is this formula here, which is capital F of S is equal to the integral from 0 to infinity of e to the negative st times the function f of t. So we've been given the function f of t as sine of 3t. So when you're asked to use the definition, you just want to take the function that you've been given and plug it into the integral here for f of t. What that's going to result in is an integral that you're going to need to evaluate. And once you evaluate that integral and evaluate it over the interval 0 to infinity, you're going to end up with a function for capital F of s. And when we talk about the Laplace transform, what we're doing is we're taking a function f of t and transforming it into a function capital F of s. And that function, capital F of s, is the Laplace transform of f of t. So really, it's just as simple as plugging into this formula and then figuring out how to handle the integral. So what we're going to say is we're going to say capital F of s is equal to the integral from 0 to infinity of e to the negative st, all that's going to stay. And now we're just plugging in f of t, which we know is sine of 3t, and then we have dt. Now, when your function f of t is an exponential function, so for example, e to the 3t, you're going to be able to combine that directly with this exponential function, e to the negative st, and integrating will be pretty simple. But in this case, we have the product of an exponential function and a trigonometric function, which is going to require us to use integration by parts. So the integration by parts formula, remember, is u times dv. When we have that inside the integral, it's going to be equal to u times v minus the integral of v du. So really, we just need to identify u and dv, and then find u, v, du, and dv. So here what we're going to do is we're going to set u equal to sine of 3t. So let's go ahead and do this over here so we save ourselves some room. So we'll say u is equal to sine of 3t, which means that dv is going to be the rest of the integral. So dv is going to be equal to e to the negative st dt. Then we want to take the derivative of u to get du. So the derivative of u is going to be du equals, the derivative of sine is cosine. We have to use chain rule and multiply by the derivative of the inside function. So the derivative is 3 cosine of 3t, and then we have dt. And then we need to integrate dv to find v. So the integral of e to the negative st is negative 1 over s e to the s negative st. Now when we replace this integral with the right-hand side of our integration by parts formula, this is going to be equal to u times v. So we multiply u and v, and that's going to give us negative 1 over s e to the negative st sine of 3t. And we're going to be evaluating that over the interval 0 to infinity. Then according to our integration by parts formula, we're going to subtract the integral from 0 to infinity of v du. So when we take v and multiply it by du, we've got 3 and negative 1 over s, so let's call that negative 3 over s, but we can pull that negative sign out in front and make this a positive, so we just end up with plus 3 over s e to the negative st, and then cosine of 3t dt. Now this 3 over s, remember that s is a constant, so 3 over s is also a constant, which means we can pull that out in front of the integral. It acts like a constant coefficient. So we'll put 3 over s in front of the integral. So then what we're left with here is plus 3 over s times the integral from 0 to infinity. And now what we see is that we have an integral that's really similar to our original integral, but we're going to need to use integration by parts again. So this time for the integration by parts, remember last time we said u was equal to sine of 3t. This time we're going to set it equal to cosine of 3t, the trigonometric function that we have remaining. So we're going to do cosine of 3t, which means dv is the rest of what's left in our integral, which is e to the negative st times dt. Then we're going to take the derivative of u to find du. Well, the derivative of cosine is negative sine, and then we have to multiply by 3 because that's the derivative of our inside function. So we end up with negative 3 sine of 3t dt. And then we have to integrate dv in order to get v, which is going to be negative 1 over s e to the negative st. So now we have this set of values. We want to replace this remaining integral here with the right-hand side of our integration by parts formula. So before we do that, let's go ahead and rewrite the beginning of this equation. Now this is the integral that we're replacing with the right-hand side of the integration by parts formula. So we want to put this in brackets, so we make sure we multiply the 3 over s by the entire integral, or the entire right-hand side of our integration by parts formula. So 3 over s times u times v. So here we have u and v. What we're going to end up with is a negative 1 over s e to the negative st times cosine of 3t. That'll be evaluated over the same interval, 0 to infinity. Then according to our integration by parts formula, we're going to subtract the integral from 0 to infinity of v du. So when we multiply v and du, first of all, we're going to get these negative signs here to cancel. Those will become positive signs. We have this 3 times 1 over s, so we have 3 over s out in front, then e to the negative st, and then sine of 3t dt. We can go ahead and pull this 3 over s out in front of the integral because s is a constant, so 3 over s is a constant, so 3 over s is a constant coefficient. So instead of the integral from 0 to infinity of 3 over s, we'll just bring that 3 over s out in front, and then we have the integral from 0 to infinity here. Now we'll rewrite the first part here. So capital F of s is negative 1 over s e to the negative st sine of 3t evaluated over 0 to infinity. Let's go ahead and distribute this 3s across these two terms here. So we have 3s times a negative 1 over s. That's going to give us a minus 3 over s squared e to the negative st cosine of 3t evaluated over 0 to infinity. And then we're going to distribute our 3s across the negative 3s times the integral. That's going to give us a minus 9 over s squared times the integral from 0 to infinity of e to the negative st sine of 3t dt. So what we want to realize now is that because this whole right-hand side here is equal to f of s, and this right-hand side here is equal to f of s, since both of these things are equal to f of s, that means they're equal to each other. So we can set this value here equal to this value here. And the reason that that's helpful is because when we set these equal to each other, we have this integral, the integral from 0 to infinity e to the negative st sine of 3t dt, on the left-hand side of our equation, and then on the right-hand side of our equation, we have the integral from 0 to infinity e to the negative st sine of 3t dt. In other words, we have the exact same two integrals. So what we can do is when these are equal to each other, we can add this whole integral times 9 over s squared. Since we have a negative 9 over s squared, we can add this whole thing to the left-hand side. And what we get, if we remember that this is essentially 1 times this integral, we're adding 1 times this integral to 9 over s squared times this integral. So we have 1 plus 9 over s squared times the integral from 0 to infinity e to the negative st sine of 3t dt. That takes care of or moves this integral over to the left-hand side, and we're only left with these other two terms on the right-hand side. Now if we multiply this 1 right here by s squared over s squared, that gives us a common denominator with this 9 over s squared, and we end up with s squared plus 9 over s squared for this value here instead. So that's what it becomes. Then what we can do is we can multiply both sides of the equation by the reciprocal of this fraction. We can multiply both sides by s squared divided by s squared plus 9. When we do that, it'll cancel this whole value, leaving us with just this integral on the left-hand side, which is what we wanted to solve for in the first place. So what we end up with is this integral here being equal to s squared divided by s squared plus 9 multiplied by the rest of the right-hand side. Now notice here that we have s squared in the numerator of this fraction, we have s here in the denominator and s squared in the denominator. That means we're going to be able to cancel one factor of s out of each of these values here. So this s is going to disappear completely. We're just going to be left with the -1. This s squared is going to become s, and this s squared is going to become s when we eliminate one factor of s from each of those values. So then we can say that we have s divided by s squared plus 9 multiplied by, since this s disappeared, we just have the -1, so we're just left with negative e to the negative st times sine of 3t. And of course, since both of these terms are evaluated over the interval 0 to infinity, let's just bring that interval to the back and we'll evaluate them together. And then here we're just left with minus 3 over s e to the negative st cosine of 3t, and we're going to be evaluating this whole thing over 0 to infinity. So now it's time to evaluate the interval. Remember that this interval relates to t. It came from our original formula here for the definition of the Laplace transform, this interval, and we were integrating with respect to the variable t. So this interval applies to t, which means we're plugging in for t, not for s. S is a constant that we're going to leave in here. So plugging in for t, first of all, we'll leave this s over s squared plus 9. We plug in our upper limit of integration first, which is going to be infinity. And remember, of course, what we're really doing here is pretending that this is, let's say, a constant b, and we're taking the limit as b goes to infinity. But essentially, you're just evaluating as t becomes very, very large. So we can think about this as negative e to the negative s times infinity times sine of 3 times infinity. And then we have minus 3s times e to the negative s times infinity times cosine of 3 times infinity. Then we're going to subtract whatever we get when we plug in 0. So we want to subtract here. When we plug in 0 for t, we're going to get negative s times 0, which is 0. E to the 0 is 1, so we just end up with a -1 out in front. So we have negative sine of 3 times 0, which is just going to be 0, so negative sine of 0. Then we have minus 3 over s, e to the negative s times 0, which is going to be e to the 0, or 1, so that's going to drop away. And then we have cosine of 3 times 0, or cosine of 0. So when we simplify what we have left, what we know is that we have here negative s times infinity in the exponent on the exponential function. So negative s times infinity, s is just a constant, which means we're going to end up with negative infinity here for the exponent. E raised to the power of negative infinity is 0. So this whole term here is going to become 0. Same thing with this term, because we're going to end up with e to the negative infinity. So this is going to be 0. And so then what we're left with is s over s squared plus 9. This negative sign here has to be distributed across the sine of 0 and negative 3 over s cosine of 0. So because both these terms are negative, this negative sign is going to cancel with both of these negatives and turn them into positives. So then we're multiplying by sine of 0 is going to be 0. Cosine of 0 is 1. 1 times 3 over s is 3 over s. So of course the 0 we don't have to worry about, and then the result we get here is 3s divided by s times s squared plus 9. We're going to be able to cancel the s from the numerator and the denominator, so then we can say that the Laplace transform f of s is going to be 3 divided by s squared plus 9. So the Laplace transform of the function f of t equals sine of 3t is capital F of s equals 3 divided by s squared plus 9, which we found using the definition of the Laplace transform.